All right, homework, you had a worksheet dealt with central tendencies and calculations of central tendencies. Solutions were provided for you also. Questions you have on anything we need to do. Now, once again, this class, in stats class, you have worksheets, you have solutions that are sitting there. I expect you to check your solutions. That's when, if you have trouble or struggle and you can't figure out how to get to a solution, then we start asking questions in class how to explain that. But outside of that, you should be able to look at the solutions, check your solutions, and if you need to, figure out a little bit how to get from point A to point B with respect to your solutions. But we will go over problems or things that you need to in class if you need me to go over something. Questions you have? Yeah? Number 6. Did you write down what we talked about yesterday in regards to how we go about doing that? What do you mean score?
Like where it says score and underneath those numbers on how to link those.
Hey, you have your homework scores, your homework average. Basically, if you look at what we did up above, your score or your average on your homework is 96. You have 4 quizzes that we said has a weight of 30%. So what we can do is we can calculate. We have homework, which is a 96, which is a weight of 2, and we said this is going to be your 20%. We have quizzes, and then we have a final, and your final grade was a 91 with a weight of 3, or with a weight of 5, which we said is 50%. So that's worth 50% of your grade. The weight of that is 5 out of 10. Okay, what you do have is you have 4 quizzes though, and those 4 quizzes, each of them have a weight of 3, which means combined together they have a weight of 30%. So what we need to do is calculate one value that would represent all your quizzes. Well, that one value that represents all your quizzes is the average or the mean of those quizzes. So if you would add up 84, 96, 94, 98, add them up and divide by 4, you get a X bar average of 93. So if you would add all those up and divide by 4, we would get an X bar of 93. This weight was 3, which tells us we have a 30% then. So each one of these, we have 96.2, 96 times 0.2, we have 93 times 0.3, and then we have 91 times our 0.5. So we can calculate those 3 weights and then add them together. The first weight to 20% of the 96 is 19.2. The 30% of 93 is 27.9. And the 50% of 91 is 45.5. So we add them up for a total of 92.6. A weight is a percent of the scores that represent your grade. Other questions? Okay, today we're going to deal with the measure of variation or measure of dispersion. How the grades are dispersed. And once again, this is stuff that we start dealing with statistics-wise that is going to be new for you. What we have is we have 2 sets of quiz scores there. I want you to calculate the mean for each one of those sets. Calculate the mean for each one of those sets. What is your X bar? I'll tell you what you get for the mean. For both of them?
Wait, oh, for the,
No. What do you get if this was our set of test scores here? What was our mean for this one? 88. All right. What was your mean down here with this one? 88. Okay, we get 88 for both of these. We add them up and divide by the total number of values. You add them up and divide by the total number of values. So if a person in a class scored an 82, 94, 90, 88, and an 86, their grade's an 88. If another person, student B, scores a 72, 168, and 2 100s, their grade comes out to the exact same 88. Okay, that is the measure of a central tendency. But if I would take a look at these two sets of data, these two sets of data give us the exact same mean. But if we take a look at the two sets of data, can we compare these two sets of data and contrast, there's your English term, compare and contrast things. I want you to compare them and contrast, and is there any differences between them, or are they pretty much the same sets of data? Okay, if I take a look at these two sets of data, are they pretty much, 82, 94, 90, 88, 86, the other one's 72, 100, 68, 100, 100. Are they relatively the same, or is there differences in regards to how they got to the exact same grade? Write down a sentence that describes any type of differences that you might see between these two sets of data. Just write down a sentence right below this. Compare these two sets of data. I want you to compare these two sets of data. Are they, if you sit there and say, oh, they're pretty much the same, okay, that's fine. Or do I see any differences? Okay, what would be, are they similar? Are they different? Why would they be different? Because both of them give us the exact same grade. Student A and student B both scored 88. But how they arrived at those 88s, was it the same or was it a little different? Sydney, what'd you write?
I think that the second students seem to have a better chance of getting their scores, but they just scored lower because they failed two quizzes.
All right, so So on 2 of them, they didn't do very well. On 3 of them, they did really well. All right, Joanna?
The second one has better test scores than the second one, or than the first one.
All right, that's fine. Grant, what do you have? Okay, more consistent. Second one is what? The second one, you said the first one's more consistent, and then the second one was what? Okay, that's fine. That's what do you have?
I kind of said the same thing as Cindy, that they did, the second student did good on pretty the tests and not so well on 2 of them.
All right. Paige?
So there was like a wider range of like test scores in the second set than the first one. The first one's kind of
Yeah. And it goes back to the idea of what Grant said, the consistency. The first one were more consistent. The second one, very inconsistent, and it's a wider range of test scores. Well, that's the measure that we're going to discuss and talk about today. Is how are the data values dispersed? Because this is more consistent. And these are more spread out, where we have the good test scores and not so good test scores. They're more spread out. The other ones up there, and that's a great word to use with it, is the idea of consistent. They were pretty much the same test scores. Okay, 82, 94, 90, 88, 86. They weren't spread out very much. But the second one was just more spread out. I have a 68 and then I have 100. Well, this is what is called in statistics the measures of variation or dispersion. When we talk about measures of variation and dispersions, these are measures of the spread of data. How is the data spread? Are they closely packed or are they spread out? Are they closely packed together, or are they spread out? They're all over the place. Or are they consistent with what they do? And that is a very big statistical measure in regards to sets of data. Have you ever heard of grading scales that were done on a curve? Grades that were done on a curve. That's what we'll talk about here. We have people that are curve busters, that really hurt us normal folk in regards to how we normal folk score on tests. Because the curve busters will skew our data and really make our grade look a little bit worse than it really is. Ways of measuring this, the first one is the range. When we take the range, this is the easiest way, the easiest one. You just take the largest test value and you subtract off the smallest value. Take the largest value and you subtract off the smallest value. That is the range. Large minus small. So if we take a look at the top one here, our range is our biggest value, which is 94, minus our smallest value, which is 82. So we have a range of 12. But if we take a look at the second one, Jane, what would be our range here? How would we find it? What's our largest value? What's our smallest value? 100 minus 68. So we have 100 minus 68, which is 32. The range of 12. The data values aren't spread out. The range of 32. That means I have more spread of the data values. Now, we need to take a look at two scenarios. And we talk about a population, we talk about a sample. A population, once again, is an entire set of people that we're doing a study on. An entire set. All the high school students in the state of Ohio. That would be a population. Down High School, we just did the sample down High School. We would just be a sample of that population. Okay, because we're a subset. Well, let's take a look at another scenario. We have the College Credit Plus classes, stats classes at Down High School. Then we state the College Credit Plus stats classes at Down High School as a part of the whole College Credit Plus group from the University of Findlay. If we just took a look at you and say, this is the group of people we want to study. We want to study the College Credit Plus class students at Down High School. And just stop right there. We can study, we have 25, 30 College Credit Plus students at Down High School that took stats between the first and second semester. We could study them. Okay? But if I said the College Credit Plus stats students at Down High School as a part of the entire group of people that take it through the University of Findlay, they service 25, 30 different schools that serve, that they teach College Credit Plus at. Okay, you as an entity taking College Credit Plus, if I take a look at you in this first scenario, would you be a population or would you be a sample? Then I take a look at the second one, College Credit Plus, as a part of the entire group of people through the University of Findlay. Would the DHS class, would you be a population or a sample here, or would you be a population or a sample here? Which one would you be in each one of those scenarios? A population or a sample? Write it down. One of those you're a sample, one of those you're a population. Which one of these are you a sample, and which one of these are you a population? Huh? Would you be a population on the first one or second one? First one. This you'd be a population. Because down here, you are a part of an entire group. You're sort of a subset. You'd be a sample here. If we were just studying you as I just want to do a study down high school stats students, your population. But I want to categorize and describe the entire population of University of Findlay's College Credit Stats or College Credit Plus Stats class through the University of Findlay. You're now just a sample. Because you need to know and determine, most of the time, most of the time those things are going to be given to you. But sometimes you'll have to think through that process. Am I a sample or population? Because our next way of describing our dispersion or the spread of data is called the variance. Now the range you have done, the range you have done. But the variance and the standard deviation is the thing that you have not done. The variance is the average of the squares of the distance. Each value is from the mean. The average of the squares of the distance. Each value is from the mean. The average of the squares of the distance. Each value is from the mean. The symbol we use is a lowercase sigma. Now, the other day we did the big sigma. It looked like an E, a pointy E. The Greek symbols, they have uppercase and lowercase also. This is your big sigma. This is uppercase sigma. Here you have lowercase sigma, which is a circle with a bill of a hat on it. So there we go. You got a circle here, and you just put a bill of a hat on it. That's your lowercase sigma. And we square that. How we calculate this? Is the sum of the value minus the mean squared divided by n. Where n is your sample size or your population size. This is your population size. This is value minus mean. So you have the sum of your value minus your mean squared divided by your population size. Why we square them? Is to keep values positive. Once again, these are all new things to you, and you need to practice them. So let's take a look at how we can do this. We do this with a table. We have our values that we had in our first group. We have 82, we have 94, 90, we have 88, and we have 86. Our average for both of these was 88. So we start out with value minus the mean. So we have 82 minus 88. Now these are things that you're going to want to work sideways with your calculator. Because your calculator, once again, we're going to be dealing with value minus the mean, which gives us -6, and then we have to square that. Now, how you can handle that with your calculator, because when we run into problems is we square -6 and we get -36, which is incorrect. So you can go 82 minus 88. Hit enter. We get our -6. Then just hit your square button. It will pull your answer down -6, and square it to give me positive 36. Because if you do -6 squared in your calculator, what are you going to come up with? Negative 36, because you didn't square the negative. So we can go 82 minus 88, get our value, and just hit your square button. That pulls your answer down and squares it to give us 36. Then we have 94 minus 88. So we subtract those two. We get 6 again. We square that to give us 36. 90 minus 88. We get a value of 2. We square that. So you work yourself sideways and then down the table. Work diagonal across or sideways across and then down the table. Then 88 minus 88, we get a value of 0. We square that, we get 0. And then 86 minus 88, we get -2. We square that, we get the value of 4. The sigma there means we have to add down. So we can add down our last column. We have to add down our last column. This is your x minus x or minus mu, value minus mean. We add down this column to give us 80. Then our variance is the sum of that last column divided by our number of data values, which is 5. So we have 80 divided by 5, which is 16. That is our variance. Now what I want you to do is recopy our values over here. And calculate your variance for your second set of data. Now you don't have to write this in here. I just wrote it in here just to show what we're doing here. We have this here tells us what we have to do. Value minus mean. My mean is still 88. So I can go 72 minus 88, put my answer down there, hit my square button, put my value there. So calculate your variance with your second group. Nice thing about the second group is you get a bunch of repeaters. When you add down that last column, Rachel, what do you come up with? 1,088. We divide that by 5, and what do you get for the variance then? 217.6. Okay, and this is our variance. Now, this is a relative concept, which means that when they talk about a relative concept, it's a comparative concept. My variance is bigger over there to the right, which means my spread of data is going to be larger. My variance is not very big with a 16. That means they're closely packed together. There's one other thing that we will do with this. It's called a standard deviation that we will look to calculate at this, when we get to the back side here. When we talk about the standard deviation, this is something that's a little bit more practical and not practical, but a lot more of a usage for elementary statistics is to look at the standard deviation. And how you calculate the standard deviation is the square root of the variance. You just take the square root of your variance. So if we take a look on the other side here. My standard deviation here is the square root of 16. So we get a value of 4. My standard deviation for the second one is the square root of 217.6. Not 14.8. 14.8. Now, rounding once again, our raw data values is the nearest whole number. That's our data values. We round our everything else to the nearest tenth. So we have 14.8. Okay? Once again, that's bigger. That means my data is spread out a little bit more. When you have a sample, the variance formula is altered. Okay, now when you're dealing with a sample variance, once again, when you use a sample, we use letters rather than Greek symbols. So we're going to be using an S. When you deal with a sample, we have x minus x bar squared, and that should be the sum of x minus x bar squareds again. Value minus the mean squareds. But what's different is we take our sample size minus 1. And the reason why is they say when you're dealing with a sample, to be more accurate with your standard deviation, you subtract 1 from your sample. I don't know why. That's what statistically they say is better. Then take the square root of that, we can get our sample standard deviation. We will start with this tomorrow here. Just to sort of reiterate what happens with a mean and a standard deviation when they grade on a curve. Suppose the mean score was 72 on a test. That was the mean score. The standard deviation was equal to a value of 8. was equal to a value of 8. How grading scales are determined at this point? This 72 is your middle C. This is your middle C. This standard deviation is your width of each grade. So the C's have a width of 8, which means if I go 4 up and 4 down, that would give me 76 and a 68. These are C's. I go 8 more to this, I get up to 84. From 76 to 84, these are B's. Above 84, these are A's. If I go down in this direction, down to a 60, these are D's. Below 60s, these are failing grades. When you get to college, more professors will start grading on curves. And the reason why is in college, it starts to become a competitive nature between students. You hear of classes when you go to college that are weeding out classes. They weed you out of a major. They use these types of scoring to weed you out of majors. Because when you grade on the curve, it's a competition. That pits your grade against your grade. Your grade goes up against your grade. Your grade goes up against your grade. It is a competition between grades. Your grade is affected by her grade. Yours is affected by her grade. I remember one of my engineering classes I was going through, I think it was thermodynamics, second class of thermodynamics. I remember getting like a 52 on the test. They hand them back. And these tests, there are 3 teachers. The tests were on Friday afternoons from 2 to 5 o'clock for everybody taking thermo. There were 3 questions on the test. Each professor did 1 question. And basically you had 1 hour for each of the questions. And you needed that entire hour for the entire question. But I got a 52 on that, and you go, ooh, ouch, that one hurt. But then you sit there and you wait for the scores to come out. The average on the test was a 45. I got a 52. So I was, when they started doing the grades out, I was at a high C on that test with a 52. That's what grading on a curve does for you. It's a little humbling. Say, when you get that test back and you see that red 52 circled on that test, you go, ouch, that one hurt. But when you start grading on a curve, I was at the upper end of the C's with that test. That's what grading on a curve does for you. There's classes that are developed, once again, to weed people out of classes. Organic chemistry. Organic chemistry is a weeding out class. Going into nursing, medical fields, chemical engineering, you have to take organic chemistries. And you have to take that. That starts separating the people. That first week after organic chemistry, as I went, okay, this is not for me. Walked out at the end of the period, walked down to the registrar's office, I said, get me out of all the chemical engineering classes and please put me into the mechanical engineering classes. So I went into mechanical engineering at that point and finished that because I could handle, that's physics. That's physics on steroids is mechanical engineering. Okay, hyper steroids. But there are classes that are designed when you go to college that are sitting there and going, that's a weedy. You'll hear somebody when if you go to college, you go to a dorm, and you start talking to upperclassmen, and you start talking about specific classes. They say that's a weeding out class. What that means is that's a class that is sitting there and separates. Do I really want this major, or do I not want this major? Do I want to go into something else?
I won't be in here next year.
Oh my gosh.
I just know that Ed didn't have me on the list, so.
But that's how people grade on curves and deal with your grading skills once you start getting into college a little bit more. We'll work on the rest of that. What I want you to do for homework is you can work on the front side here. Work on the front side of this worksheet. The back side we'll do tomorrow. That's the part that we skipped out on with respect to notes. So work on the front side here. All you're doing with the front side is calculating your standard deviations and variances and your ranges. All right, adios, folks. Have a good. I get you. Have a good day.